Hello. Today we are going to study about reactions, very important, which are called as redox reactions. So what are redox reactions? I am sure you have studied about various types of reactions like combination reactions, single displacement reactions, double displacement reactions, and so on. Right? Now redox reactions are very important types of reaction which stands for reduction and oxidation. So you have reduction also taking place and oxidation also taking place in a reaction. Such set of reactions we call them as redox reactions. Now most of the reactions that we see around, they are all examples for redox reactions. Say like the most important reaction which gives us energy, the glycolysis, is an example for redox reactions. Then we have photosynthesis, which is one of the most important reactions on earth, which keeps life sustaining. That is also an example for redox reactions. Then we have rusting of iron, where we have iron oxide that forms off from the iron metal, right? I'm sure you would have seen that rusting of iron. That is also an example for redox reactions. And then we have bleaching, dyeing of clothes, which is done quite commonly, and that is also an example for redox reactions. So we know where redox reactions happen and what redox stands for. But how to define reduction and oxidation reactions? So to define the reactions, what we will do is we will take up few reactions and try to understand the nature of these reactions. Okay, so let us take the first reaction, which is iron oxide reacting with carbon monoxide to give us molten iron and carbon dioxide. So where do you come across this equation? This is seen in our blast furnace, right? I'm sure you have studied about the extraction of metals, the metallurgical processes, and in iron extraction you would have seen the methods to convert iron oxide to molten iron. And how do we do that? We add carbon monoxide. Now notice this reaction very carefully. You see that in the process iron oxide is losing oxygen and becomes molten iron without oxygen, right? And then we have carbon monoxide that gains oxygen and gets converted into carbon dioxide. So observe this equation carefully and notice what is happening to the oxygen. Iron oxide losing oxygen, whereas carbon monoxide gaining oxygen. So redox reactions or reduction and oxidation reactions can be defined based on the loss or gain of oxygen. Oxidation, the name itself suggests that there has to be addition of oxygen. So here you see that carbon monoxide becomes carbon dioxide, and that is an example for oxidation reaction. And what is happening to iron oxide? We see iron oxide is losing oxygen, so I can call this as a reduction reaction. Makes beautiful sense, right? So addition of oxygen is oxidation, removal of oxygen is reduction. Now, do you see all the chemical reactions having oxygen in them? Might not be, right? Sometimes there are many reactions which actually does not have oxygen at all participating. Now in such a case, is it a redox reaction in the first place? And if it is redox, how to define in that condition? So let us take up one more example for our study. Now in this example, we have taken hydrogen sulfide. And this hydrogen sulfide, we make it react with chlorine gas. I'm sure you would know what the products would be. It is a formation of hydrochloric acid with the formation of sulfur. You notice the reaction here, there is absolutely no oxygen present. In this condition, how can I define oxidation and reduction? Now, many people initially thought that it might not be a redox reaction in the first place. But however, because of the various complexities which we are going to learn very soon, okay, they realized that there is some kind of relationship between this reaction, which does not involve oxygen, and the first reaction which is having oxygen. So what to do now? So they had to give one more definition to tell us about what is oxidation and what is reduction. So now let us notice here, we see that in H2S we have hydrogen and H2S gets converted into S, and chlorine we see addition of hydrogen taking place. So not only with respect to oxygen, with respect to hydrogen also redox reactions can be defined. So we can define oxidation as a process where there is removal of hydrogen. You can notice here there is H2S and there is S here. So there is removal of hydrogen, and that is oxidation reaction. And addition of hydrogen, which is happening with respect to chlorine and hydrochloric acid, is called as reduction. So basically oxidation has right now two definitions: addition of oxygen or removal of hydrogen. And reduction has two definitions, which is removal of oxygen and addition of hydrogen. So this makes pretty good sense of the definition that involves oxygen and hydrogen. Yeah. But if in chemistry, I'm sure you would know that there are so many reactions which does not involve oxygen or hydrogen. But we know that there are some kind of bondings that are formed, some kind of bond breaking, bond forming, all this happens. So there has to be one more way of defining redox reactions. So that is when we came up with one more definition for redox reactions. Okay, and let us see what that is. Now let us consider the first equation, which I am sure you all would have learnt it, 2Mg giving rise to magnesium oxide. A pretty good equation. I am sure when we burn magnesium strips, it burns with that bright white light to give us that white powder, which is the magnesium oxide. Right? Now this whole reaction can be written in two reactions. Let me tell you what is happening at the electron level. So we have magnesium, and this magnesium, what is happening is it loses 2 electrons and forms an ion which is magnesium 2+. Okay, and then we have oxygen, which takes up this electron and becomes negatively charged ion, an anion. Now these two ions would combine together to give us 2MgO, right, magnesium oxide. So basically here we see that 2 magnesium, right, and then these ions would form the magnesium oxide that we were discussing. Notice this reaction, you see that there is loss of electrons happening and the gain of electrons also happening. Now with this we have one more definition that is given for redox reactions. The first one is what we call as the loss of electrons, which is happening with respect to the magnesium, where it is giving away the electrons. So there is loss of electrons with respect to magnesium. We call that as oxidation. And then we have oxygen accepting the electrons or oxygen gaining the electrons, and that is called as the reduction. Now basically what we did was we have three definitions for defining redox, reduction and oxidation reaction. Oxidation can be defined as addition of oxygen, removal of hydrogen, or loss of electrons. And then reduction reactions can be defined as the gain of electrons, addition of hydrogen, or loss of oxygen. Okay, now you see in this whole process, okay, magnesium is the one which is undergoing oxidation, right? Now we can simply say that magnesium is getting oxidized in this process. And similarly, oxygen, because it is undergoing reduction process, we say that oxygen is getting reduced. So this is about our definition of the terms reduction and oxidation reaction, or the redox reactions. Okay, now what we will do is we have one more very important term with respect to your examinations that you need to study, and that would be something called as a reducing agent and an oxidizing agent. Okay, reducing agent and oxidizing agent. Now this picture should actually summarize what reducing and oxidizing agents actually mean. Imagine we have a substance, okay, we will call that as A now. Now this A has got 2 electrons. Now we know what oxidation is, loss of electrons is oxidation. So we have this A which loses its electrons and becomes A. So what is happening to A? We say A is getting oxidized. A is undergoing oxidation reaction. Compound A with ions, with electrons, would become A without electrons, right? And similarly we have B. Now B will take up these 2 electrons and forms a complex. So B is undergoing reduction. B gets reduced in the process, and you see that this whole process, B gains electrons, right? So we know what oxidation and reduction is and what is with respect to the electron movement. But now let us see what reducing agent and oxidizing agent mean. Please note, the one which is undergoing oxidation, or the one which is getting oxidized, will be the reducing agent. Basically, I can say reducing agent is that agent which can give away its electrons so that it can become oxidized. Reducing agent is the one which has the ability to lose electrons during a chemical reaction. Okay, now this is a very important understanding of what reducing agent is. Similarly, we have B which gains electrons, so we have oxidizing agent, right? And this oxidizing B is considered as oxidizing agent because this has the ability to gain the electrons. Okay, this is the one which helps for this substance to accept electrons. So that is what we call as the oxidizing agent. Okay, so oxidizing agents and the reducing agents are something that we very commonly use in our chemistry labs. Now you might be wondering, why exactly do I need to study all this? Okay, many times for certain reactions to take place, you might have to add certain reducing agents, certain oxidizing agents, and so on. And maybe you should also be able to predict the compounds that would be formed. And for all these things, you need to know which one would be a better reducing agent, which one would be a good oxidizing agent, what are the conditions for the oxidizing agent or the reducing agent to be a very good oxidizing agent or a reducing agent. Okay, so that is what we mean by oxidizing and reducing agent. Now once we are thorough with this, let us go to the next part of our understanding of something which is very important with respect to your examinations of your KVPY level. So after we discuss about what reducing agents are, the next thing that we would do is we would discuss about the oxidation numbers or the oxidation states. Many times you should remember that oxidation numbers and oxidation states are used interchangeably, and these are different from the formal charges. Okay, why do we need to know something called as oxidation numbers in the first place? Let us talk about that. You know that whenever there is a bond making or bond breaking, there is a very important part. Okay, there is very important part in an atom that is participating in the reaction, and that is the valence electrons, right? That would be the valence electrons. Now these valence electrons are the one which are participating in the reactions. However, you should know that to either work as an oxidizing agent or a reducing agent, there are a very specific number of electrons that can be transferred from A to B, right? And this number of electrons is something that we need to know to determine the characteristic of an atom or an element in a reaction. So what we try to do here is we are going to define that by a number which is called as oxidation number. Now generally when we are talking about ionic compounds, it is very easy to tell what the oxidation numbers are because it's ionic interactions. But in covalent compounds, imagine that we have sharing of electrons and we need to know the oxidation numbers, or let me say the number of electrons that are participating in an equation or in a reaction or in forming a particular structure. The whole process becomes slightly difficult. That is when, we have the help of oxidation numbers coming to rescue us. So we define the oxidation numbers for a particular element in a compound and try to see how that changes. Basically, the whole understanding of oxidation number will help us to keep the track of the electron movement during a chemical reaction. And for that, we follow certain rules. Okay, let us see what the rules are. The first rule is that the oxidation number of an uncombined element is 0. So what does that mean? Suppose I am talking about any element, be it sodium or oxygen, anything, you see that the oxidation number is 0 itself. Why do you think that it has to be 0? It has to be 0 because there is no gaining electron or losing electron in the first place. So it becomes 0. Makes sense, right? So that is the oxidation number, which sometimes I have referred to as ON in further slides. You can see that it is represented as ON. That is represented as 0. Now suppose I take any neutral compound like say sodium chloride or benzene or anything which is a neutral compound. Okay, it should not be charged. Then also you see that the sum of oxidation numbers of all the elements in a compound is 0. Say for example, if I am taking sodium chloride, as a whole sodium chloride would have the oxidation number as 0. But individually if I take, sodium will have +1 and chlorine will have -1. We will discuss about that in some time, right? So that would be the sum of the oxidation numbers of all the elements in a neutral compound will be 0. Now let us go to the next rule, which is the sum of oxidation numbers of all the elements in an ion is equal to the sum of the charge on the ion. Let me say I am talking about hydronium ion, which is H3O+. Now in H3O+, we know that it is positively charged, right? It is positively charged. So if I add the oxidation numbers of 3 hydrogens and 1 oxygen, it will be +1. That is what it says. The sum of oxidation numbers of all the elements in an ion is equal to the charge on the ion. Then we have the fourth one, which is the more electronegative element in a substance is always given a negative oxidation number. So in a compound, first we try to find out which is the most electronegative element, and the most electronegative element is always given a negative oxidation number, because electronegative means it is pulling the electron more towards it, and therefore obviously it will have a negative charge or say negative pull. So we call that as a negative oxidation number. And we should know by now the periodic table, and fluorine is the one which has the highest electronegativity. So we have the oxidation number of fluorine always as -1, right? And then we talk about the oxidation numbers of hydrogen. See here, the oxidation numbers of hydrogen is always +1. Okay, but sometimes you can see that it can become -1. Now when can it become -1? Only when this hydrogen is combining with a less electronegative element. Now here your periodic table understanding should come to the rescue. You should know the periodic table, and you should have a clear idea of which elements would have a lesser electronegativity than hydrogen. So normally it is +1, but if it is binding with an electronegative element, it becomes -1. Okay, and similarly, just because hydrogen is +1, there is one simple trick that I would like to tell you here. The group 1 elements will always have oxidation numbers of +1, and group 2 will always have an oxidation number of +2. And similarly, you see the oxidation number of oxygen is always -2, okay, always, okay. However, in peroxides it becomes -1, and by chance it is combining with fluorine, then oxygen's oxidation number will be positive. That is because fluorine has a higher electronegativity, right? So this is all about the rules that we generally discuss when we discuss and we follow whenever we are assigning the oxidation numbers to the compounds, to the elements in the compounds, and for ions as well. Okay, so with this basic idea, we will be trying to apply all these rules and try to find out the oxidation numbers for various elements, and also try to learn how to balance the equations, balance the redox reactions in our next video. Okay, so wish you all the best and study well.